Hey everyone! In this video we're going to be doing another circular motion problem. This time it's tension on a rope. We're going to highlight where solve the tension force, experienced by a 4-meter rope when a 250-gram mass is swung around in circles, we're swinging it over our heads, and each rotation takes zero point 0.8 seconds. That's what we're solving. We're solving the tension on that rope as we swing this mass around and around in circles. Well, the equation for this is centripetal force is equal to mv squared over r. The centripetal force is the force that pulls that mass, wants to like throw it out into oblivion. The tension will be the force that counters that. So when we solve centripetal force, it's the same value. Let's go ahead and identify what we know. The mass, that's 250 grams, but we got to write that as kilograms, so it's 0.25 kilograms. Our radius, we also know that's 4 meters, but we don't know the velocity. All we know is that each rotation takes 0.8 seconds. So we're going to go back to an old favorite equation, is V equals D over T. We need to solve the distance that mass swung around. Well, since we're swinging it in circles, we're going to use the equation for the circumference of a circle, which is D equals 2 pi r. We fill in our radius that we know, so D equals 2 pi times 4. I'm just going to clean this up for now as 8 pi, and I'm going to fill it in directly as 8 pi, just so that I'm not rounding it several times while I do the question. So I just fill 8 pi in. We get velocity is equal to 8 pi divided by the time it took to swing it around, which is 0.8 seconds. We're going to get a velocity equal to, when we plug that into the calculator, 31.4 meters per second. Now we know our velocity. So we want that force centripetal, that force that we have to like hang on to, or else that mass swings out and flies through the air. That's the tension on our rope. So our force centripetal is equal to our mass, 0.25, multiplied by our velocity, 31.4. Don't forget to square that. All divided by the radius of the rope that we're swinging. So it's the length of the rope, 4 meters. We get that our force equals 61.6 newtons. So the centripetal force, that force that wants to launch that mass out into the wild world, is the exact same force of tension that we have to hang on to, or else that mass will go flying. If that 61.6 were stronger than our rope would break. If we couldn't hang on with it like a grip that could hold on to 61.6 newtons, we would let go of the rope, it would fly away. If you have any questions, please feel free to leave them down in the comments below. Otherwise, I hope that this was helpful, and thanks for watching.